Hello everyone, welcome to Memoneet. I am Aprajita, your chemistry SME, and I am back with another lecture on some basic concepts of chemistry. So I hope you remember that this chapter is going to come in your first test, right? That is your BPT 1, Bhramastra part test 1, and we are discussing the very important concepts of this chapter, right? So let me tell you what we are going to discuss today, students. So today we are going to discuss the very important mole concept. So whenever this term mole concept comes in front of us, all of us get terrified, no? So let me tell you, there is no need to get terrified because we are going to discuss the very basics of these mole concepts, and I'll tell you some easy ways to solve these questions so that you can get hold of this concept. Apart from that, firstly we will learn about the atomic mass, the molecular mass, and everything, like all the basics we will be learning today. Alright, so we will be starting with these topics, okay? But before that, do you remember one thing? I gave you one question in the last session. In the last session, we talked about the significant figures, calculation of significant figures. Then we talked about the laws of chemical combination. And I gave you one question to solve. I hope all of you have done that, right? So we will be discussing that question first, and then we will be moving ahead and starting with our today's topic. So let's see what was the question, and please check if you have done it right. If not, you can see where did you go wrong. Alright, so let's have a look here, students. So this was your question. The density of the solution is 2.5 gram per milliliter. Then the mass of 2.5 ml solution in correct significant figures is. So I told you that density of the solution is given. That is 2.15 gram per ml. And the volume is given, which is 2.5 milliliter. We need to find out the mass, that too in correct significant figures. So as we know, students, that density is what? Mass upon volume. So the mass would be, of course, density multiplied by volume, right? So in this case, what we need to do is multiply the density 2.15 with volume 2.5. So when we are going to solve it, it will come out to be 5.375 grams. But is this our answer? No, right? Why? Because we need to give the answer in correct significant figures. And I told you that whenever we are multiplying two numbers, the number of significant figures will not exceed the one that is there, right, in least significant figures. So here there are two numbers, 2.15 and 2.5. 2.15 has how many significant figures? 3. And 2.5 has 2. So my answer will not have more than 2 significant figures. So I have to round off 5.375. So 7 is there now. So it is greater than 5. So it will be rounded off to 5.4 grams. So the answer according to the correct significant figures is going to be 5.4 grams, which is your option C. And let me tell you, students, that this question was your previous year question. Okay. Now, you might have got amazed. Yes, this question was asked in your Neet 2022 examination. Now, where you will find all these PYQs? In our NTA PYQ book section, right? Where we have provided all the questions that were asked from 2019 to 2024 examination, chapter wise, and that too topic wise, so that it becomes easy for you to understand all these topics and all these questions. So you don't have to go here and there. You don't have to actually go through the internet to find the questions. You will find all the questions in this particular book. So please go through that, okay? This is also one of the part of your Bhramastra test series preparation. Okay, you have to go through the PYQs. So once you watch all these video lectures, go through the in-class notes, the NCERT line by line, and of course go through the PYQ book. Solve all the previous year questions that are asked, and definitely you are going to get good marks in the BPT. Okay. So you will find all the PYQs there, go through them. Not just the question, you will find the crisp and the detailed explanation as well. Okay, isn't it amazing? So please go through that and practice all the previous year questions, which are very, very, very important. Okay. So let's come back to our today's concept, that is the mole concept.
Okay, students. So before directly jumping to the mole concept, I want you people to understand the meaning of atomic mass and molecular mass, because that is something very basic and very important. So we all know about atoms, right? And we know that each particular atom has its own particular mass. So nowadays we have advanced techniques like mass spectrometry, through which we can easily calculate or find out the mass of any atom. But let's just go back to 19th century. When these studies were going on, scientists were trying to find out different ways, different methods to find out the atomic mass. At that time, mass spectrometry was not there, so it was not possible to calculate the mass of atom. And you know that atom is not any like something you can just put it on a weigh scale and measure it, right? They are microscopic particles. So actually it was very difficult to calculate or to find out the mass of atoms. So what was done? A relative method was chosen. So relative, what is relative means? So relative means that a particular like something, some atom was taken as a standard, and with respect to that the masses of other atoms were written. So hydrogen atom being the lightest one, its mass was taken to be 1. Just 1, no units. Okay, nothing was there. And relative to the hydrogen atom, the masses of other atoms were taken. Okay, but then it was thought that like it did not give us the required results and everything. So as like researches went on, oxygen was selected. Then ultimately, see, we don't have to go into that research part. Ultimately, we need to see that carbon 12 was chosen as the standard atom. So you know that carbon 12 is one of the isotope of carbon. So the mass of carbon 12 was taken to be 12 AMU. Now what is AMU? It is atomic mass unit. It was taken to be the unit for writing the atomic masses. So the mass of carbon 12 was taken to be 12, and with respect to that this 1 AMU was established. So what was 1 AMU? What very important, what is 1 AMU means? It is the mass which is exactly equal to the mass of, or you can say to 1/12 of mass of carbon 12 atom. Okay, means if I divide the mass of carbon atom by 12, I will get the value of 1 atomic mass unit. Okay, so let me give you one example. So if I say ki 1 AMU, the value of 1 AMU is actually 1.66 into 10 to the power, or 1.6605 to be precise, into 10 to the power minus 24 grams. Okay, so this is the value of 1 AMU in grams. You know what is mass of a hydrogen atom in grams, of course. So 1.6736 into 10 to the power minus 34 grams, 24 grams, sorry. Now you might be thinking, ma'am, if we know the masses in grams, what's the need for AMU? So do you remember these values, these long values for every atom? No, right? It is very difficult to remember them. That's why we wanted something easy where we get the masses in some whole numbers, okay? Some complete values. So let's see what will happen. So if I want to calculate the mass of hydrogen atom in atomic mass unit, what will I do? I will divide 1.6736 with the value of 1 AMU, which is 1.6605 into 10 to the power minus 24. So it will come out to be 1.0078, and to round it off, it will be 1.0080 AMU. So this actually is taken to be the mass of hydrogen atom. So of course, we take it as 1 only. But yeah, to be accurate, it's 1.008 AMU. So this is how the atomic masses are being calculated, by taking the carbon atom as the standard. Okay, relative atomic mass. Nowadays, instead of AMU, U is used, which is unified mass. Okay, values are same, nothing different. But you know, students, that there are isotopes, right? Atoms with different atomic masses are there. So if of course, like most of the atoms will have the isotopes. So in that case, what do we do? So whenever we have isotopes, the average atomic mass is taken. Okay. Now, how to calculate this average atomic mass? Okay. So for that, we have some formula. Let's say if I am having an atom with two isotopes whose mass is M1 and M2. Now, if we know their percentage abundance, means in nature how much this isotope is found. So let's say the percentage abundance of M1 is P1 and M2 is P2. Then the average atomic mass, please note these formulas, okay? Whatever formulas I'm giving you, these are important, please note. So it would be M1 multiplied by P1 plus M2 multiplied by P2 divided by 100. Okay, that's a very simple thing, you can do it. Let me take an example of chlorine. Now chlorine exists as 35 isotope and second one is 37. So for 35 isotope the percentage is 75% and for M2 the percentage is 25%. Now if I want to calculate the atomic mass, it will be 35 into 75 plus 37 into 25 upon 100. So it will come out to be 35.5 U. So for the atomic mass of chlorine, we will take the value as 35.5. So this is how your average atomic mass is calculated. Okay, for every atom, right? You can calculate it for other atoms as well. Now that is why you will see that most of the atomic masses are in decimals because we are taking average. To make our calculations easy, we take it like for carbon, if I take the average atomic mass, it comes to be 12.011 U. But for easy calculations, I will be taking it as 12. But this is the exact value, the average atomic mass. Okay. Alright, now if I talk about the molecular masses. So what is molecular mass? So you know when atoms combine, they form molecules, right? So what will be the mass of that particular molecule? Let's say I am having a water molecule. So this water molecule is having two hydrogen atom and one oxygen atom. So what will I do? I will add the masses, right? So what will I do here is I will add the mass of hydrogen, which is 1 U, and for oxygen, which is 16. So mass of water would be 2. Since I have two hydrogen atoms, 2 into 1 plus 16. So it will be 18 U. So 18 AMU or 18 unified mass will be the molecular mass of water. In the same way, students, you can calculate the molecular mass of methane. Let's say CH4. So it will be the mass of one carbon atom plus, since there are 4 hydrogens, so 4 into mass of hydrogen atom. So what would that be? It would be 12 plus 4 into 1, 16 AMU or 16 U. Okay. So these are the values we can use. Now there is one more term that you must know, that is formula mass. So you know for ionic compounds, for example, I have sodium chloride. It is not existing as a discrete molecule. Okay, it's an ionic compound. So you see it is existing as this three-dimensional structure. There are no discrete molecules here. Each sodium ion is surrounded by 6 chloride ion and vice versa. Okay, you can see that. So in such molecules, we are not using the term molecular mass. We are using formula mass because we are not having one particular molecule here. Try to understand. We are having this three-dimensional structure with lot of sodium and chloride ions. But one formula of sodium chloride is NaCl. So the formula mass will be mass of one sodium atom plus mass of one chloride. Okay, so that will be 23 and 35.5. So it will come out to be 58.5 U. So the way of calculating is same. It's just that the name is different. We are not using the term molecular mass, but we are using the term formula mass because here we are not having a particular molecule. Okay, they are having this three-dimensional structure where we have lot of sodium ions and chloride ions. So this is how we calculate the atomic mass. Okay, if we know the atomic masses of any atom, we can easily calculate their molecular masses and the formula masses. okay, or formula unit mass. Now we will be talking about what is a mole. Okay, so firstly we need to understand what is a mole. So you know, students, that atoms and molecules, they are very small in size, right? They are microscopic particles, but the number is large, right? And extremely large. So to handle such large number of entities or particles, a convenient unit is required. Okay, so just like we have 1 dozen, how much 1 dozen is? It's 12, no? Similarly, 1 score, it's the quantity which is equal to 20. 1 gross is equal to 144. Similarly, we have a quantity which is 1 mole, which is actually taken to account the amount of substance, or you can say it is actually used to deal with the number of elementary particles, atoms, molecules, ions, and like all your microscopic particles. So 1 mole is considered to be the SI unit of amount of a substance. Okay, so it's a fixed quantity, just like if you have 1 dozen of bananas, it will be 12 bananas. Now, if I buy 1 dozen of oranges, will it be something more than 12? No, right? It will be 12 oranges only. So, similarly, we have this quantity which is 1 mole. Now, what is its value? It is an experimentally determined value, okay? Which is 6.022 into 10 to the power 23 elementary particles. Now, these values, students, these are going to be fixed values. This will not change. If you have 1 mole of anything, 1 mole of atom, molecule, it's going to be a fixed number, and this number is something very important which is known as Avogadro's number. Okay, so this is known as Avogadro's number. Alright, and this is a fixed quantity. So this 1 mole is very important from chemistry point of view, because to count the number of atoms, to count the number of molecules, ions, all means all the elementary particles, we use this 1 mole quantity. And please fix this in your mind that this is a fixed quantity. It is not going to change. Okay. So it means, students, if I say you that I am having 1 mole of hydrogen atoms, then how many atoms I am having? Can anyone tell? Yes, it's going to be 6.022 into 10 to the power 23 hydrogen atoms. Similarly, if I am having 1 mole of water molecules, let's say, okay, so how many molecules are there? Is the value going to change? No, right? I've just told you that the value is going to be same, which is 6.022 into 10 to the power 23 water molecules. Okay, the value is going to remain same. That is not going to change at all. All right. So when we have the knowledge of this 1 mole, I think now 1 mole is clear. What 1 mole is? Just a quantity. So when we have the knowledge of this 1 mole, I can calculate the mass of 1 mole of a substance, right? So see, I am having 1 dozen bananas. So their weight can be 1 kg, 1.5 kg, 1.2 kilograms, like something like that. So similarly, 1 mole is a fixed quantity having this much number of atoms or molecules. Then if I calculate the mass of 1 mole of any substance, okay, anything, if I am taking mass of 1 mole of hydrogen atom or water molecule, so that will be known as molar mass of that substance. So if anybody asks you what is the molar mass of hydrogen atom, don't get confused. It means that we have been asked the mass of 1 mole of hydrogen. Okay, molar mass means mass of 1 mole of any substance. And what is that equal to? That is very, very easy. Just now we have discussed atomic, molecular, formula unit mass, right? So that's going to be used here. So molar mass is just equal to the atomic mass or the molecular mass or the formula unit mass of any substance in grams. Okay, let me give you a very simple example. What is the mass of an oxygen atom? It is 16U, right? Now if I ask you the molar mass of oxygen atoms, means the mass of 1 mole of oxygen atoms. Okay. So that is going to be what? 16 gram per mole. Okay, 16 gram per mole will be the molar mass of oxygen atom. So it's the mass of actually 6.022 into 10 to the power 23 oxygen atoms. And this is the mass of one oxygen atom. Okay, that is the difference. Alright. So this mass now, it is also known as gram atomic mass. Alright, if we talk about the atoms, it's gram atomic mass. If we talk about the molecules, it is gram molecular mass. Alright, so gram atomic mass means the mass of an atom in grams. In grams. Alright, so that is the meaning of your molar mass. Now, once we know what is molar mass, what is 1 mole, then we are able to solve the problems that are given to us. Okay, so before that, I just want to tell you a flow chart. Like, I'll show you a flow chart, and from that you will understand all the things. That flow chart I want you people to draw in your notes. Wherever you are taking the notes now, please draw it in your notes, because that will be helpful for you to understand. The notes should always be very crisp, right? So if we use those notes, that would be very easy for us to understand. All right, so let me show you that. So this is your flowchart. See, don't just get confused. Sometimes it's 6.022 or some books have written 6.023. That's not a problem, okay? So students, I told you 1 mole in terms of particles. If you have atoms, so it's going to be Avogadro's number of atoms being 6.023 into 10 to the power 23 atoms. Whereas if you have molecules, it's going to be 6.022 or 6.023 into 10 to the power 23 molecules. Then in terms of mass, it is 1 gram atom of that element. Okay, let's say 1 gram atom means it is, if I'm talking about 1 mole of oxygen, so it means it is equal to 16 grams of oxygen. 1 gram atom. 1 gram molecule. Here you can write 1 gram molecule. So 1 gram molecule means, if I'm talking about water molecule, so 1 gram molecule of water means 18 grams of water. That is 1 gram molecule. Similarly, 1 gram formula mass, like you can take it for sodium chloride. So it will be around 58.5 grams of sodium chloride. So it means that is 1 mole of sodium chloride. Okay. So this is the chart that will help you to find out the meaning of 1 mole. Alright. Now I just need to tell you how we are going to do the questions. So the questions come in this way. First of all, you have to calculate the number of moles. Okay. We need to calculate the number of moles. How we are going to calculate? So if I am asked to calculate the number of moles from mass, I'll give you 3 formulas here. Please note that. Okay. For example, let's say I am asked to tell you the number of moles in 64 grams of oxygen. Okay. 64 grams of oxygen may I have to calculate the number of moles. So the formula is number of moles is always denoted by small n. These like these things you should know. So it will be whatever given mass is there, that is W, and the molar mass of that substance, that is going to be capital M. Or molar mass in this case can be the atomic mass if we are talking about the atoms, it can be the molecular mass if we are talking about the molecules. Okay, that is the formula. Now if I ask you how many moles are there in 64 grams of O2. O2 means I'm talking about oxygen gas, means I'm talking about oxygen molecule. So what is the molar mass of oxygen molecule? Yes, calculate it. So that will be 2 into 16, no? Because there are 2 atoms, so it's 32 grams. So I just need to put the value 64 gram per mole and 32. So it will come out to be 2 moles. Simple, isn't it? So this is how we can calculate the number of moles from mass. Now from particles. If you are given so and so particles, like if they have given you that find out the number of moles in 12.044 part into 10 to the power 23 particles of sodium atom. Okay. So how many moles? So if you are given the particles, just write the given number of particles. And 1 mole of substance has how many particles? Avogadro's number. So you will just divide it by Avogadro's number. You will get the particles, means you will divide it by 6.022 into 10 to the power 23. You will get the number of moles. Now one more thing I want to tell you about the volume. Okay. For gases, if I talk about gases, 1 mole of any gas at STP acquires 22.4 liters of volume. In some places, you will find out 22.7 also. Now, why? That will depend on your pressure. So, you know what is STP. So, 22.4 liters will be when the pressure is in 1 atmosphere and the temperature is 273 Kelvin. And it will be 22.7 if the pressure is 1 bar, because there is a slight difference between 1 atmosphere and bar. That's why there is slight difference in the volume. And 273 Kelvin, again temperature means 0 degrees Celsius. This is STP. So if they have asked you that calculate the number of moles in so and so liters of carbon dioxide gas, okay, so what you will do, number of moles will be the given volume divided by 22.4 or 22.7 depending on what condition is given. So you will get the number of moles, right? So this is how we can calculate the number of moles, and by just using these formulas only I can calculate anything. So if I can calculate given mass also, I can calculate molar mass also, I can calculate the particles also. Okay, suppose they have told you that you have 10 moles of water, how many particles will it have? So you will just multiply 10 with the Avogadro's number, right? So that will also become easy if you get this flow chart. I will show you this flow chart, easy to understand and very crisp. Alright then, so here is your flow chart, students. Please note it, okay? This is very simple. I'll help you understand, okay? Whatever you are asked, okay, that's given in these circles. So you just have to do according to the flow chart. Let's say you have to calculate the mass in grams. See, the question will be calculate the mass of, see, if they have given you number of moles, okay, calculate the mass of 5 moles of carbon dioxide gas. Okay, so I'm just giving you an example how to use this flow chart. So what are the two things that are given to you? Mass and number of moles. So we will use these two. Now from mass, I have to go to number of moles. So see this arrow? You will just have to like multiply, or you can say divide, multiply or divide with mm. Now what is this mm? This is the molar mass. Okay. So what we are given here is we are given the 5 moles. Okay. And I have to find the mass. So from 5 moles to find the mass, I will have to multiply with the molar mass. Instead of molecular mass, write molar mass, because molar mass can be atomic mass also if they're asking about atoms. So in that case, you will say it's atomic mass. So mm means molar mass. So I am given, so we know that mass of 1 mole of CO2. What it would be? Now find the molar mass of CO2. So you know it will be 12 plus 2 into 16. That is 44 gram per mole. This is the molar mass. So 1 mole CO2 ka mass is 44 gram per mole. So just for 5 moles I have to calculate, right? So I told you to multiply with molar mass. So 44 into 5 that you will do. So it will come out to be 220 grams. Okay. See, this is so easy. Fine. This is how we are going to use this flow chart. Let me give you one more example. Okay. So, let's say I am having this number of molecules. Okay. And I have to find out the mass, or you can say the number of moles. So, firstly, I will find out the number of moles by dividing it by the molar mass. Or here in this case you will say you will divide it by the Avogadro's number, that is Na. Okay, let me show you how it is to be done. So let's say for example students, if it is given that how many atoms are there in 1 gram of sodium. Now they have not given directly the number of moles, they have given the mass in grams, which is 1 gram. From it you will first find the number of moles. So number of moles would be 1 gram means given mass, and C, what you will do, divide it by the molar mass, right? You have to go this way, no? So divided by the molar mass, which is 23. So it's 1 upon 23, that will be the number of moles. Now I have to find the number of particles, okay, or the atoms. So in this case it's atoms. So once I have got the number of moles, I will multiply it with the number of particles, because here the number of particles is Na, 1 mole. So I will here instead of mm write Na. So here you will be getting the number of moles multiplied by the Avogadro's number, means 1 upon 23 into 6.022 into 10 to the power 23. This much atoms would be there in 1 gram of sodium. So this is how you are going to use the mole concept to calculate any values, okay? To calculate the number of atoms, to calculate the mass, anything. Alright. So again, more and more you practice, this concept would be clear. I think now you will not find it difficult, because we have understood it in a very simple way. Just remember these flow charts that I have given you, the formulas that I have given you. Just make note of it and you will find it very easy. Okay. Now I am giving you the question C, just like I told you in the last session. So the question is, which one of the following, these type of questions come in your exam, okay, will have the largest number of atoms. Alright, largest number of atoms. So the options are 1 gram of gold, second is 1 gram of sodium, third is 1 gram of lithium. These are all solids, okay, and fourth one is 1 gram of chlorine gas. Okay, so how many atoms are there, that you have to find out, and then you will be finding out the largest number of atoms. So again, this is what you are going to do. Firstly, find out the number of moles, then multiply it with the Avogadro's number. Okay, so please do it. Post your answers in the comment box. I'll be waiting for your answers, and I will feel really good if you people give answers, okay? So don't worry whether it's right or wrong. Just try to solve it on your own first and give me the answer, and we are going to discuss it in the next session. So that was all about the mole concept from here, okay? So this whole session was dedicated to mole concept only, because this is a very important one and important to understand, because that's an important part of your physical chemistry portion also, right? If you understand mole concepts, further calculations become easy. Alright, so in the next session we will be talking about the remaining topics of this chapter. We'll be talking about stoichiometry, then some terms related to solution, that is molarity, molality, and all of that stuff. Okay, so for today this is it. See you soon in the next session. Until then, take care, keep learning. Bye bye. Thank you.